we're on the last section of 7.6, solving logarithmic equations. Last time in 7.6 we solved exponential equations. So that was when the variable was in the exponent. This time we're solving equations where you're going to see log there. But interesting enough, the way you often solve log equations is rewrite it as an exponential. The way you let me say that again. The way you solve a lot of log equations is by rewriting it as exponential, and then getting the same base and solving. So let's look at. We're going to look at 4 examples of different types of log equations. And log, it might have natural log. All the rules apply the same when you have natural log. So we're going to solve these. And when you solve a log equation, you do have to check solve. The directions will be solve, check for extraneous solutions. So sometimes extraneous means like extra that doesn't work. So you have to kind of go back and check and make sure that it makes sense. You can't just blindly solve it and leave your answers there. So number 1, natural log. We'll start with the easiest kind. Natural log 7x minus 4 equals natural log of 2x plus 11. Okay, this is so intuitive to solve here that you probably already started the problems without even needing the lesson, because it's just human nature to look for patterns, and you see that the two sides look the same, and so you don't need the log part anymore. You just match up these. So these expressions, 7x minus 4 equals 2x plus 11, and now we're doing algebra 1, solving a linear equation. So we want to get all the x's together on the same side and the numbers on the other, so we subtract 2x from each side and we add 4 to each side. I'm going to do those steps all in one. And divide by 5 on both sides, x equals 3. So let's just make sure that, let's double check. If I plug it back in, you get 21 minus 4 is 17. Natural log 17 equals natural log of 17. Yeah, works. Next, number 2. Let's take log. Now this one is substantially harder, but not for us. Okay, we want to solve that. I want to get x alone. So you're looking at that, and you can't just like divide both sides by log 2 to cancel this out. That's not at all. It doesn't mathematically work at all. But what we can do, like I said, is here's the key, is rewrite in exponential form, which is why we've spent so much time practicing doing that. Rewrite in exponential form. That's going to be your friend, that strategy. So we've got 3 parts to these log equations. We have a base, which is right here. We have an exponent, which is right here. And we have kind of what we'll call like the answer right here. So in exponential form, the base is 2. The exponent raised to the 5th power equals, and the answer is x minus 6. So just rewrite in exponential form. And now this we can solve. 2 to the 5th power is 2 times 2 times 2 times, it's not 10. Please don't say it's 10. It's 2 multiplied by itself 5 times, which should be 32. So x equals 38, and we should double check. 38 minus 6 is 32. 2 raised to the 5th is 32. Yes, it works. Okay, stepping it up a level, getting a little bit more difficult. Are there any questions so far? Okay, let's try this. Now let's use our expand condense skills. Log 5x plus log x minus 1 equals 2. Let me just separate this out. So now we have an equation with two different log expressions in it. So that definitely steps up the level. But this is why we learned to condense expressions, because I can't do anything with this right now. I can't even write it in exponential form. It's too complicated. So you just look at the left side, and you just condense it. So remember the laws of the properties of logs. Log A plus log B is log AB. So we're just going to make it into one expression. So we just simply multiply these two together like that. Now this problem is already much easier, because now I can do what I did in problem 2. Write it in exponential form and solve. But I want to make sure we're okay on that step. To go from here to here, I don't want two different log expressions. I want just one. So I condense, and we practiced that skill by itself before. So it's 5x times x minus 1.
So the log doesn't add on another log?
Yeah, so you don't add, it's not like 2 log or anything. It just becomes 1. Yeah, good. So now the base here, even though it's invisible, before we could see it, but it's still there. The base is 10, and you need to know that that's called the common log, base 10, whenever and that's on your calculator. So you go the base 10 raised, what's the exponent? 2, right? The exponent's over here. 10 to the second power equals, and here's the answer, 5x times x minus 1. That was when I said rewrite in exponential form, that's exactly what I did right here. And now there's no log. That's how you get rid of the log, is by writing it in exponential. This is algebra 1, solving this equation. So 10 squared is 100. Use the distributive property. This is great review. And now we, what kind of equation is this? Quadratic. This was unit 2 of the semester, solving a quadratic equation. So what do you have to do to get x by itself? Can we ever get x alone? You really can't, because you have an x squared and an x. You're not going to be able to isolate it. So what do we do instead to solve quadratic equations? You factor. You get it, first you get it equal to 0, and then you factor, and then you use the zero product property. Super, super important algebra 1 stuff. So I'm going to get everything to the same side. 5x squared minus 5x minus 100 equals 0. Okay? And I'm going to factor. So I'll just leave the 0 over here. So when you factor, you always look for what first? The GCF, which is 5. Let's take out the 5 first. We always want to simplify our life, so get rid of that. And now this is a basic, because I did that, I can do a shortcut, a basic diamond problem to solve this, because there's no leading coefficient. So I just say what multiplies to what? Negative 20 and adds to negative x. Negative 1, actually, the coefficient. I can just do the shortcut. So what multiplies to negative 20 and adds to negative 1? I just... Negative 5 and 4. Good. So x minus 5, x plus 4, it's factored. And now zero product property, either this equals 0, which it doesn't. 5 will never equal 0. Or this equals 0, or that equals 0. So the answers are 5 or negative 4. Apparently, but we have to check. So the thing is, though, if you plug in, you have to check, especially with negative numbers. If you plug a negative number back into the original problem, do you see how there's no way you can take log base 10 and get a negative answer? You can't raise 10 to a power and get a negative answer. It's not going to happen. So you have to eliminate that negative answer. We're going to do one last example of a similar level problem as this one. And that's the end. So I'm moving on. Last one, number 4, is right here. Number 4, last example, is log base 4 of x plus 12 plus log base 4 of x equals 3. Okay, so you go ahead and you try that because you have all the skills you need. Solve for x and go ahead and try that. Okay, so hopefully I need like time lapse. I don't know where pause is. Hopefully by now you've condensed the two expressions into one. So that's x plus 12 times x, or x times x plus 12 equals 3. That should have been your first move. And then, can someone tell me what this is in exponential form so I can get rid of the log? You'll be on video. Yeah? Lauren says natural log of 4. Try again. Well, okay. What's the base? 4. 4 raised to the, what's the exponent? 3, good. 3 power, we'll do it as a class, good, equals the answer, x times x plus 12. See, no more log. I rewrote it in exponential form. And then, what type of equation do I know this is already? It's a quadratic equation. I can tell I'm going to get x squared here. So, that's a good review. 4 cubed is 64 equals x squared plus 12x. Get everything on the same side. I like having everything on the left. And these, I don't even have to do a full diamond and rectangle to factor something like this because the leading coefficient is 1. So I can just say what multiplies to negative 64 and adds to 12. And that will give me my factors. What are those numbers? If you don't know, you can start breaking it down. 64 is 1 times 64. Start with 1. 2 times 32. 3 won't go in evenly. 4 times 16. Do we get it yet? Yeah, it'll always be in this list. If you just list methodically. And then what sign?
Negative 4.
Okay. X minus 4, x. Factoring is a super important. Going into the final exam, factoring is very important. So x equals 4 or negative 16. And does the negative 16 work? No, it does not. So there we go.